Good morning, good afternoon, good evening from wherever you have joined today for this PG Day conference. I'm really excited to present my topic in this conference. Thanks to the team at Snowflake and everyone who has put their efforts into making this PG Day possible. I see that PG Day happens every year and it's such an interesting event for me because this always keeps me thinking that okay, for the next year's PG, what can I do, like what can I present which is innovative and which is something that we have actually used at our company in the last year. Today I'm going to talk about exposing PostGIS data with OGC standard. Particularly I'm going to talk about two products, PG Tile Serve and PG Feature Serve. A little bit introduction about myself. I am Krishna Luda. I am founder of Rotten Grapes Private Limited. We are a software based company from India where we create geospatial tools, geospatial products for companies across the globe. We have headquarters in India. We have one office in Singapore, one office in Berlin, Germany as well. We have been creating softwares all the way up to government level. Also, we are maintaining SDKs for Python, JavaScript, Ruby, etc. So the topic of today is divided into multiple things, and I believe like this will help us to understand how do we think about adoption of any particular tool, right? So first is that why do you need these products? Why do you need PG Tile Serve and PG Feature Serve? What are the current products available? So for this need, what are the current tools that are available in the market? Then what do these products particularly do which are probably better or probably faster compared to the other products? Then we will have a look at get started, where we will actually get our hands dirty in setting up the products, and then we will also look at some of the advanced features that exist. And then I will also talk about complementing products that can go hand in hand with PG Tile Serve and PG Feature Serve. Lastly would be the contact us slide. So if any one of you needs to connect with me, you can reach out to me easily. Alright, so why do we need this product? So imagine that you already have your data, especially vector data, available in your PostGIS. Given the fact that PostGIS is the most advanced database out there, given the fact that PostGIS is the most advanced database out there for the geospatial need, the chances are pretty high that your data might live in PostGIS. And now you are looking to share the data. This can either be sharing with the dashboards which are not built by you, so it can be any other tool where you need to ship your data to, or it can be a web mapping app that you have built, so OpenLayers or MapLibre or Leaflet, anything like that. Or you just want to do some analysis, so analyst related work using QGIS or ArcGIS or even in Python. Now in this case, we need to expose the data without setting up some heavy software. So GeoServer is very amazing software. We use it all the time, but sometimes it becomes very heavy to run. Obviously there are ways you can do optimization, but with a basic GeoServer setup, it might become too heavy. And it's also XML based WMS WFS configuration, so it's not very much API friendly, or it's not very much web app friendly. Nowadays all the REST APIs majorly expose their data using JSON, right? So and then there are of course performance bottlenecks. If you don't optimize your GeoServer correctly, your Java settings, or how do you want to expose the data and all, then it might become problematic if you are planning to serve tons and tons of data. So what are the current products available? There is a traditional GeoServer, so it's a full OGC stack. So in a way this is like one tool that you need to cover your entire application's OGC needs. It exposes the data with WMS, WFS, WCS, as well as with the modern OGC APIs like features, styles, coverages, maps, etc. Then you also have a Python based system like PyGeo API, which is also very similar to GeoServer, but it's written in Python and it exposes your data using OGC APIs. It's quite lightweight, and if you're interested into PyGeo API, you can check out my YouTube channel. Just search for Krishna Luda PyGeo API and you will see a couple of videos about it. Next is raster API. So T-Tiler is one of the complementary product that we use along with the PG Serve stack. But T-Tiler is mostly used to expose the raster data. So if you have a cloud optimized geotiffs or a ZAR sitting either on your local machine or maybe in your bucket somewhere, you can use T-Tiler. And the alternate to the PG Tile Serve, which is a vector tile service, is the Martin. Martin is also quite fast, but it only gets half of the job done. So you can only expose it as a vector tile. Now the modern approach that we like to use is we use PG feature serve to expose the raw data as a GeoJSON. We use PG tile serve to expose our raw data in a vector tile format so that the data is secured as well as the styling is managed by frontend. And then we use T-tiler for all of our raster needs, and that becomes our modern geospatial stack. So let's understand what do these products do. So PG feature serve serves your PostGIS layers as a GeoJSON. So in a very simple word, if you have like 100 tables in your PostGIS, all of those now become a GeoJSON layer using PG feature serve. It follows the OGC API feature standard, which means it has all the things that you need like items, filtering, pagination, ordering, etc. It provides collections which will give you list of all the collections, items which will give you the actual items, and you can do SQL filtering, pagination, metadata, etc. With PG tile serve, you can actually serve the data as a vector tile, and this is really powerful because if you look at modern maps, let it be OSM or Google Maps or something like that, you will see that in compared to a couple of years earlier, now all the rendering or all the styling happens on the front end itself, and that's exactly why you now have these beautiful products where you can customize your map and the way it should look from front end itself. This is powerful, right? And because of this you can make a really good cartographic maps, for example daytime, nighttime, snowy area, deserted area, etc. This is because the original data is stored in a vector format back in the database, but it is exposed as a vector tile. Next is that it also follows OGC API tiles standard. So this means that this is also OGC API compliant, and the outputs are fast rendering PBF files. One of the great things about PBF files is that PBF files are not like exactly georeferenced, because PBF files are referred by their Z, X and Y, which means the zoom, the X address of the tile and the Y address of the tile. So even if someone goes to the network tab and tries to download the data, sure they will get the PBF file, but it will not be exactly georeferenced. And this is particularly ideal for your web mapping need, because if you are creating a web application with OpenLayers or MapLibre or something like that, you want to expose the data, but in such a way that nobody should be able to download that data and use it in their own application. So in order to do that, you can actually store your data in PostGIS and expose them as a vector tile. Now let's get started. There are a couple of ways how you can set up the PG feature serve and PG tile serve, and if you're on Ubuntu or Windows or even Mac, you can actually download the PG feature serve and PG tile serve. So for example, if I just go to the, or if I just simply search for crunchy data PG feature serve, I will go to the GitHub repository, and from here I can check out that how do I download this. For Linux there is a zip file available, for Windows also there is a exe file available, for Mac there is a file available, but the one that I like to use most is the Docker, because it's just easier to set up. Alright, so if you just want to test things out, Docker is going to be your best friend. Alright, now there are some things that we will need to understand whenever we are working with a tool like this. Because PG feature serve and PG tile serve is tightly coupled with the PostGIS, in order for us to run this, we have to also give the configuration. The simplest configuration can be just the information about your PostGIS. For example, the DB connection for me is going to be PostGIS with the username as user, password as password, and localhost 5432, and my database name as GISDB. Now apart from that, then other things you can give, like what is a web server port and what is the base URL going to be, etc. You can read more about this in the official documentation. You will see a lot of things that you can pass along with this basic things. Alright, so you can actually refer to this PDF, and that's like one PDF that you download and it will have everything that you need. So as you can see over here, if I don't want to create a configuration file, I can just expose this variable database URL, and then just I can use that. And as I said, the one that I like is the Docker way, and I'm going to actually use Docker to show you about things in this particular video. So let me open my terminal. Let me open it on a new window over here. Alright, and I'm going to go to my desktop, PG day, cd into PG day. Alright, and I'm going to simply copy this so that I can explain you what's going on over here. So we are starting with one more PostGIS so that I'm not hurting my internal PostGIS that I'm using, and I'm exposing that to the public port of 5431. Then I have a pgtile serve which is internally it is running at 7800, but I'm running it on 7801, and I'm only giving a database URL which is actually this particular PostGIS. Okay. And similarly, I am also using PG feature serve, which is also the image that is available, and it also needs only one thing, that is the database URL. Alright. I am using PG admin just so that I can also show you things via web application. That's all. Now that my Docker Compose is created, let me do Docker Compose up. Okay, it looks like I already have the container running, so let me just stop all the containers and then we will start it again. There you go. So now you can see that my PostGIS is running. Let me open it on a Docker Compose desktop. So my PostGIS is running at 5431, my pgtile serve is running at 7801, my feature serve is running at 9001, and my PG admin is running at 5051. If I go to PG admin, I can log in with the credentials that I have used in my configuration. So that is admin@example and admin. So let me try to log in quickly and connect my database. So PG day, and this is going to be PostGIS. The database name is going to be GIS, I think. Let me check that. Yeah, and then the username password is going to be Postgres. There you go. So we are able to connect to our Postgres. Now, before we jump in, let's understand the documentation, how it's going to be. So you will always have like /collections, then /collections/layers, and then /collections/layer/items to get a particular item. And if you're using vector tile, then you're going to have like /tiles, which will expose the data as a tiles. Now it's time for us to jump into the demo. So the first thing that we will do is we will load the data via QGIS. So I do have QGIS open over here, and I think I have also made connection to the Postgres. So let me try to refresh, and there you go. So you can see that the connection is there, and I have also downloaded some data related to Estonia from the Natural Earth website. So I have OSM buildings, I have POIs, and probably I will also download the roads. Okay, so I have a point, line, polygon data, and what I'll do is I'll simply rename them first so that it's easier. So points, buildings, roads. Alright, and I will just drag and drop them into the my database. Now that this is happening, let's explore the endpoint. So the endpoint for our pgtile serve, looks like this is done. So the endpoint for our pgtile serve is going to be 7801. So let me just copy that and paste it over here. And there you go. So you can see that we have 3 layers available with us. And then the endpoint for our PG feature serve is going to be 9001. So let me also open that. And here also under collections we have 3 collections available with us. If I just click on preview, you can see that it will, I'm not sure if the data is there yet, but let's say which data is there. So it looks like points is there. So if I were to open the points layer, you will see that we can see all the points available in our data as a vector tile. And if you want to get a confirmation, you can open your network tab and go to the network, and if you zoom in, zoom out, you will see that the PBF files are being generated, and this PBF file actually contains your data. Alright, so you can click on anyone, get more information about this particular point. Similarly, you can click on any one of the building and start seeing the polygons of the buildings as well. And there are few settings that are managed by PostGIS itself, which makes your applications super fast. So you can see that, imagine we are looking at the entire Estonia's data, but not all the data is going to be downloaded. Based on what is your zoom level and where the cluster of the data is, PostGIS automatically loads only that much data. But as you start zooming in, you will start seeing the more and more data starts populating onto your screen. So this is also one of the advantage of using PostGIS and vector tile serve, is because doesn't matter how big your data is, they will find out a way that how you can look at your data in a easier way. So now you can see that if I start zooming in, I will start seeing more and more data. With PG feature serve, it's essentially the expose GeoJSON. So if I click on it, let's say if I click on it, you will see that we are getting the roads, and over here we have given that the default count is going to be 10, which means that only 10 features will be returned at any point of time. Alright, now let's check the endpoints. So when I go to 7801, you will see that we have multiple endpoints. The first one we have is the index.json, and if I open it in a pretty print, it's like a JSON file which contains all the layers that exist, and you get some basic information like the ID, the name, the schema, and then the detail URL, which means that if I copy this and if I paste it over here, that's where I will see information about this particular public.buildings layer. So I see information like all the columns that exist, as well as the geometry type and the bounds, the center, and then the tile URL. So this tile URL is particularly helpful for us, because if we were to copy this and if we go to, let's say, PostGIS, okay, the buildings is still copying, so let's try to do it for something else. Let's go with points. All right, so if I go to the JSON of the points and if I were to copy this, I can copy this, go to QGIS and look for vector tile. So layers, add layer, add vector tile layer, and I will give a new connection with the name Estonia points, and my URL is going to be this PBF file. Okay, add, close, and now you can see that we have these points which are coming actually as a tiles. So it's not a GeoJSON representing the points, but this is actually coming as a tiles itself. So you can see how easy it is. You can use QGIS to expose this particular data. You can use QGIS also to import the data into your database, and then you don't have to worry about like refreshing the application altogether. As and when you will add new data, the data will be available to you. Alright, so we have seen that with PG tile serve, we have index.json, which represents all the layers. Then you have schema.layer, which means the public.buildings or points, which actually exposes the metadata. And then you have public.building/zxy, which actually exposes your data as a tile server. Alright, now when you look at the PG feature serve, this one is more organized, because it also allows you to expose the API. So you can also see that, okay, you have a collections API, and when you click on it, you are going to get all the collections that exist. So let me actually try to show you from here, because it's easier to see. So when I click on view collection, I think our data is live now. So okay, so when we look at the collections, we see three things, and this is a HTML representation. If I were to click on JSON, then I'm going to get a JSON which will have collections as a list, and it will contain this public.buildings, public.points, and public.roads, which are the actual data that exists over there. Okay, then you have collection schema.layers, which is again like if I click on any one of this, for example, if I click on this .json, now this is going to give me the metadata about this particular layer. So I get the geometry type and all the properties that exist. But if I were to look for items in it like this, then I'm going to get the actual GeoJSON representing the data that exists in it. So that's how we get the items from the PG feature serve. You can pass various parameters along with it, like limit and pagination and all. We will have a look at that later. So just like how we implemented this in QGIS, you can also implement that in open layers by simply creating a MVT layer and then exposing your data using MVT. Okay. Now let's talk about a few advanced features. So one of the features that I absolutely love and we use a lot into Rotten Grapes whenever we create applications is that we allow users to filter it directly from the SQL filtering itself. So what it does is that you don't have to keep on creating functions which will do your basic filtering. If you have used GeoServer in the past, you know that SQL filter is such a powerful tool. It allows you to filter based on attribute, it allows you to filter based on the geometry and everything like that. So that's why, like, if you are planning to use if you want to use SQL filter, definitely check out PGServe stack. This is like really amazing. Now let's see this in action actually. So what we would like to do now is that, for example, if I open the points and if I click on any one of the point, you will see that we have an F class where some information is given. So for example, this one is tourist info, this one is fast food, like that. So let's say that we are only interested into getting the fast food data. Alright. So what we can do in that case is that I will look at my vector connection and I'll just simply change it. So Estonia points edit connection, and then I will do filter is equal to F class is equal to the one that I want. So what do I want? I want fast food. Alright, fast food. And as soon as I click OK and reload this layer, now you will only see the points which belongs to the actual F class name is equal to fast food, and all the other layers are gone. So you see, this is exactly how you can use SQL filtering into your system. You can also do the same thing with the geometry as well. So I created this layer last night where I was trying to only load the data within a particular bounding box. And as you can see, like if I were to close this, we are only getting a particular data. So that's all the things that we can do with the PG tile serve as well as PG feature serve as well. And because again, like if we are going to expose the data, that means that it has a geometry column. You can use geometry columns and other SQL filtering. For example, if you go to SQL filtering in GeoServer, you will see a couple of good examples that exists over here. For example, I can obviously do things like numerical or text based search, but I can also do filter based on something like this. So I can have a B box and then I can pass the geometry, or I can look for within or contains or overlaps, touches, etc., etc. So this will also allow us to only get the data that we are interested in. Now what about functions? So functions are also very important because using functions we can actually create our own custom, not layers, but the kind of like a alias to the layers or alias functions where we as a user can pass some information and then we will still be able to expose the data. Now before we move into that, let's talk about the production security. You can deploy these PG tile serve and PG feature serve as an application and then expose them using Nginx or Caddy. You can use HTTPS for like using Let's Encrypt, or if you have purchased SSL certificates, you can use that. You will have to enable the authentication because the only authentication that we provide when we start PG tile serve is the username and password that you want to use to expose the data. Certainly this is not the most secure way out there, so you will have to club your PG serve stack with something on the front to manage the authorization and authentication. Caching also helps a lot because if your data is not going to change, you can obviously add a caching layer using etag or last modified in the headers, and you can use Cloudflare or Nginx for caching. And this really saves a lot of time because imagine that if you are creating a service where the data is going to be dynamic, so you cannot like cache it all the time or like make a PM tiles out of this, but you still need to cache it with some sort of expiry. So like this is possible, and as I said, like executing SQL functions is also possible. For example, here in this particular presentation slide, I've created a function known as nearby Estonia points, and I give a lat long and I give the radius, and it will try to find out all the points within that particular lat long and within that radius. One thing that we have to understand is that whenever we are creating functions, we must have a schema with the name PostGIS FTW, and inside this schema all these functions should live so that you can expose them. So over here you can see that once you create this, you can actually call the functions, and you can also see like the functions as a tab available over here, and as you will add functions, those functions will be available over here. Now the limitations of PostGIS that we face is that there are no strong default authentication layer. So that's why I said like you'll have to club this with any kind of backend application. Maybe you can build a fast API application to manage your authentication, or maybe you can use a service like a OAuth or something like that. You will need to write your backend code for authorization, wrapping endpoints, caching, etc. So like if you don't want to expose the PG serves API like 7800 or 9001, if you don't want to expose that, you can actually wrap those API endpoints in your own backend, and you will still need a solution for the raster layers, and that's exactly where T-Tiler comes into the picture. So this talk is not about T-Tiler, but T-Tiler helps you to serve the cloud optimized geotiffs. It is built in fast API, which means that you can actually do pip install T-Tiler and use it in your existing application itself. And it is perfect for raster data set. It doesn't matter if it's a single band or RGB or multi-band image. Martin is also a good alternative to pgTileSurf. It also exposes your data from PostGIS itself. It is built in Rust. It's extremely fast. It supports caching and multiple tile schemas. But it works only when you need the tile APIs. So you will still have to use PG feature serve for feature APIs. And that's all from my end. Thank you for attending. Now before we wrap up, I would also like you guys to invite to the FOSS4G 2026. So if you're from a geospatial background and if you work around the open source geospatial data, we are doing a FOSS event in India, and I'm really glad that I'm one of the the lead chair on this thing. We are organizing it in the January of 2026, which is like only a couple of months away. And if you have any query related to FOSS4G or PG serve stack in general, or if you have any business inquiry, you can reach out to me at krishna@rottengrapes.tech. I mostly sit in the headquarters, but I keep on traveling. So yeah, that's about it. And if you're interested into learning more about Postgres and PostGIS, I also have my own course available. So you can just go to krishnagloda.com/courses, and here you will see the ultimate PostGIS course. I'm still building it right now, and that's why it's super cheap right now. So it's almost like $10-12 at the moment. Because I'm building it, I am trying to create more and more content to it. But once this is done, it will be like around $40 is what. So if you need any kind of help or support, please reach out to me. This is my email ID, krishna@rottengrapes.tech, and I hope this talk was useful for you. Thank you. I'll see you soon.